it may look a little funky when to deal with it, right? And it's all it is just notation purposes, okay? So for example, when it comes to the operation systems, so we can add functions, it's going to look like this. It's going to be f plus g and then parentheses with an x. All that's saying is we're going to add each individual function together. That's it. That's all it really says. Okay. Again, all of these are just notation purposes to describe what's happening here. Okay. So that's pretty much it. Okay. We're not distributing the x. I know in my past examples, I've seen people do that. We're not distributing x. We're just saying this is exactly that, meaning we subtract the individual functions together. Okay. And it's pretty straightforward when it comes to it. So let's just see an example. It'll probably be easier to see that when it comes to it. Okay. So let's suppose we have given, let's just say f, given f of x there. Missing a little f. So given f of x, g of x, and h of x. So three different functions here. Okay. Let's first do f plus g of 1. So according to this definition, right, I'm just going to write exactly what that means. In this case, x is going to represent it as 1. So this is the same thing as finding f of 1 and then g of 1 and then adding them together. So this goes back to your exam actually, right? So figuring out what f of 1 is, so you plug in 1 in for the f. So 1 times 4 is 4, minus 3 is going to be 1, plus 1 into g function. So 1 times negative 2 is negative 2. Negative 2 plus 12 gives you 10. So the final answer is 11. And that's it. That's all you're really doing when it comes to these operations of functions. Okay? So let's try a couple more. Let's try g times h, let's say 2. Good. You just look, that means you're just going to be doing each one individually. So just g of 2 times h of 2. So now we're just going to plug in 2 in for the g. So negative 2 times 2 is negative 4. Negative 4 plus 12 gives you positive 8 times h of 2. Now we just plug it into here. All right, so it's going to be a little bit more work. So this is going to be 2 squared, that's 4, plus 2 minus 1. This is 4, 6, minus 1 is 5. So the final answer is to multiplying those, so that gives you 40. And there you go. Any questions there so far? No? Not too bad? Okay, cool. Okay. All right. So the most difficult you're going to be seeing is, well, what if I don't give you a number? I just call it x. Well, again, I'm just going to go by what the definition says, right? So definition is a minus, so just f of x minus h of x. Okay. And now it just literally becomes a trick question. What is f of x? Well, it's literally 4x minus 3. So I'm just going to 4x minus 3 minus, and what is h of x? Well, that's x squared plus x minus 1. And there you go. So literally you just plug in the exact functions. So whenever you don't have a number, you just call it, y, x, or whatever it is, you're just going to copy exactly the functions down. And in this case, goes back to, again, to the first class, right? Order operations. So first distribute this negative, so we minus x squared minus x plus 1, and just collect like terms. And now you don't get a number out, but you get another function out. And there you go. Any questions so far in A, B, or C? Yep, all good so far. Okay, so in that case, let's try another one like that. I'll give you guys more examples of this. So let's say we want some crazy one like this. because you could see something like this. We'll make it easy. That's lovely. Child abduction. Okay, sorry about that. All right, so what if you have to use all three itself? Well, same thing, right? I'm just going to write them the same way we have them here. So minus means subtract. So I'm going to be f of 0 minus g of 0. That's the first part. And then this one we're adding. So it'll be plus h of 0. And now again, we just plug them in individually, and then we're just going to subtract and add the answer. So f of 0 means I just plug in 0 into here. That's going to give you -3 minus, plug in 0 into here. That's just going to be 12 plus, plug in 0 into this one, and that gives me -1. And again, now we just collect like terms, right? So -3 minus 12 gives you -15 minus a -1, -16 as your final answer. So any questions where now you use all three, or you can, the thing is you can use multiple ones at the same time and just use, when it comes to it. So everybody good with operations of functions, right? Just like numbers, you can add, subtract, multiply, and divide. Everybody comfortable? Okay. All right, so as of now, I don't know if you guys are going to go into a higher math or like go into a pre-cal or anything like that, or you guys are going to stop here. But if you guys go into pre-cal when it comes to it, this is actually going to be a very interesting topic. It's a brief introduction to pre-cal, and it's called the difference quotient. Okay? So as of now, we talked about slope, right, of a line, and that's a key thing. We only know how to find the slope of a line. Remember that was y equals mx plus b, and m was our slope. But we all know that line, there's more than just lines in the world, right? There's curves, right? Like, there's curvatures like this way, right? So the question now becomes, how do we find the slope of a curved line, not just a straight line, right? So these are just straight lines, okay? And in order to do so, we're going to be using this equation here. Well, I kind of just give you guys. So we're going to be using, given this like curvature, how do we find the slope of that? It's actually pretty interesting. What we're going to be doing is we're going to be picking 2 points like that on the actual line. And we're actually finding the line that crosses those 2 points. And that's pretty much the theory behind this, something called the difference quotient. And again, you get far more elaborate in pre-cal, but it's a good introduction here to see, what all this actually, comes into play itself. Okay, so that's essentially what the difference quotient is okay, I'm going to pick 2 points on this curve, and I'm going to draw a line through it, and that's what we're going to be calling the slope of the curve. Okay, again, that's the key thing. It's going to be the slope of the curve itself. Okay? And here is the equation itself. Okay? So it is, I just call it DQ for short, Dairy Queen. It's f of x plus h minus the original function, all divided by h. Okay. Now, the key thing about the difference quotient is you want to simplify until the h is canceled. Okay, so that's when you simplified as much as you can. Whenever you can simplify and cancel out the h at the bottom. Okay. So here's an example of how to find the difference quotient here. So we want to find the difference quotient of the function -3x plus 7. Okay. So the first thing you have to do is figure out what this value is. Okay. And that means I'm going to plug x plus h everywhere I see an x. So you're literally going to substitute x plus h right here. So it's going to look like this. And then you just distribute. And there you go. That right there, you're going to insert here. Okay. So now it's going to be minus the original function. So it's going to be this minus that. And that's where our next step is going to be. So again, this is just from the first part minus our original function there. And again, now we just simplify. So distribute this negative and just collecting like terms, right? So now we just get this. So in other words, this whole thing at the top simplifies just to negative 3h. Okay. And now all you do is divide it by h and simplify. If you go to the next page, that's exactly what we do. So negative 3h divided by h, and notice the h is canceled. So therefore, the difference quotient is negative 3, or the slope is negative 3. And it does make sense, right? Because we started off with a line, right? And we know what the slope of a line is. It should be negative 3. And it does work. It gives me negative 3. So believe it or not, this equation works for anything, not just curved lines. It actually works for straight lines as well. It's because you just proved it, right, when it comes to this. But it's more precisely done when we have curves itself, you know, the understanding of that concept there. Okay. All right, so for some reason, this space was supposed to be up here. So I don't know what happened. But we're going to do some examples so you guys get a little bit more custom with the difference quotient. So I'll leave this here, and we're going to do some examples so I can have the equation there. So let's find the difference quotient of the function x squared minus 3. Okay, so according to our little example here, right? First thing we want to do is we're going to plug in x plus h everywhere you see an x, just like we did in this example there. Okay. So to be x plus h squared minus 3. Okay, and now we want to simplify. So just remembering x plus h squared is the same thing as x plus h times another x plus h, which means we're going to have to FOIL, right? So we just FOIL here. We should get that. So on this side, we get x squared. We can put these together. And then the minus 3. So don't forget your minus 3, right? Goes down. So that is step 1. That's what we got here. That's our step 1 there. Now step 2, we're going to subtract what we just got minus our original. That was our next step. So this is what we got. Minus our original function. Like that. So just minus it. So distributing. Gives you that. And notice things do cancel, right? Just like over here. Actually, a lot of stuff canceled in the first example, and most of the stuff is actually canceled out here, right? These 3's cancel. Negative 3 positively go away. And notice x squared and negative x squared also go away. So what's left over? So we have 2xh plus h squared. Okay. So that is the top. Right? So that's the top here. And now our last thing is just divide by h. So our difference quotient is 2xh plus h squared over h. Okay. Now, like I said, you want to simplify until you cancel out this h. So therefore, we have to do a little bit more work than we on the other one. We're going to have to factor out an h from the top. So if I factor an h out, what's left over is just the 2x. And over here, just one of the h's. Now we have that. And now we have the exact same scenario as we had on the last example, where the h's cancel. So now they cancel here. H's cancel there. And your answer is just 2x plus h. And that is your difference quotient, or the slope of this curve. So, any questions there at all? Yep. You guys sure? Okay. All right. So now let's get a little bit more difficult. Okay. So again, this is the one I'm about to give you is the most difficult you'll be seeing. And I may or may not give you one like this in the homework, but just in case I did, I want to give you guys a little bit harder example. So again, let's find the difference quotient of, let's suppose now I have 2 over x. Okay, so first, I'm going to find f of x plus h, meaning I just plug in that everywhere cx. So that's just going to be 2 over x plus h. So that wasn't too bad. Right? Much easier than plugging that into there. All right, so maybe look not as difficult as the last one. So we're pretty much done with step 1. So now we go on to step 2. So it's going to be 2 over x plus h minus our original function. Okay. So we have that now. So now here is where the difficulty lies. So unlike over here, when you put them together, just add and subtract. Here, however, it goes back one section. Again, back to your exam. So how do we put these together? You need to find the least common denominator. And again, these aren't too bad because the least common denominator is a combination of both of them together. So the least common denominator is exactly that. Okay. So therefore, we need to multiply what we're missing. So on this side, what we're missing that we have here is the x plus h. Same thing there. And on this side, what we're missing is just the x. So this is going to be it's a little bit more work than the top one. Okay. All right, let's see what we get. So we just multiply. Distribute here. And now we can subtract them accordingly, right? Okay, so let's see. So it's going to be 2x minus 2x minus 2h all over x and that. Now, if you're wondering why this is a positive, this is a negative, remember this negative distributes to both the terms, that's why. So before we go any further, any questions so far of the work? Everybody comfortable? All right. So again, notice, cancel, cancel. So we just left with minus 2h over all of this. Where did the x over x come from? Oh, so same on this side, right? What are we missing on this side that we have on our LCD? The x, right? We have the x plus h. We don't have the x itself. Just like here, we have the x, but not the x plus h, top and bottom. So it's like saying this, 4 over 3 plus, I don't know, 1 over 2. So LCD is 6, so I need to multiply this by 2 and this by 3. So same process as that right there. So you consider the 2 as the x, and this is the 3 on that side. Right, so we're almost done. Fortunately, not completely done, right? So the last thing we have to do is divide this by h. And you may think, okay, what in the world is happening here? But remember, let's just write this as it's supposed to say. So this is the fraction divided by h. Okay, now remember, if you guys remember your rules about division, there's no way we can divide fractions, right? So we can only multiply fractions. So hopefully you guys remember that rule, that whenever you divide fractions, you flip the side and change it to a multiplication symbol. Right, so just a quick little note, that's what you do when it comes to fractions. And now just multiply straight across. And again, you notice the h's will cancel out as well. They go away, and we get finally our answer. And there you go. So again, this is the most difficult you'll see because there's a lot more work just converting stuff like that.
So as long as the h is within parentheses, we don't have to cancel it out. It's just everything outside of that.
Correct. So, I did cancel the bottom h. That was the key thing, right? So you always want to cancel this h out when it comes to it. So it's okay if you have h's, except, this h when you divide has to somehow cancel at the top. Yeah.
Got it.
Any other questions? Okay, very good. All right, and the last topic we're going to talk about in this section is called composition of functions. So I'm not sure if you guys have seen this. This is a pretty popular section, and they always teach it in Algebra 2, and then again, repeat it here because it's such a big emphasis in math as well, is it's function within a function, basically. Okay, so essentially what's happening here is, let's say I have a starting point. Okay, and let's say you have a starting point of 1. Okay, and then I go into this function g, and I get out 3. Right, I just plug in 1 into g, I get out 3. And then I plug it into another function, let's call it f, and I get out -5, for instance. Okay, so what's happening is this 1 jumped to 3 and then jumped to -5. Okay, so in math is, well, what's an easier way to state this without saying this too much in wording, so make it too complicated when it comes to it. And that's what something called composition functions come into play. So we say there's got to be a way from going to here all the way to there, instead of just going loop, 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 and just bypass all that work, right? How do we state that? And this is how we state it here. It's f composed of g. So this open circle is not a multiplication symbol, it's a composition, compose. Okay? And how this is defined is f composed to g. Or in other words, you first do order operations, so first do g, then you do f. So you're just bouncing off to go to the very end. So your final answer would be, what does 1 finally end at, which would be the -5 in this case. So this is the last part, if you want to do the operations of functions itself. Okay? And here's some couple examples. I've already done out for you, but I wanted to give you guys just go through them when it comes to it. So first we do f composed of g of 5. So now we have a number, right? So what we want to do is we always want to write it how it is supposed to be. So the 5 is the x, so we're going to write it as exactly that. Notice I just wrote down the definition of what it is. Okay? And now order operations, I first have to evaluate g of 5, meaning I'm going to plug in 5 into g and see what we get out. So that's the first step. So plug it into here. We get 20 minus 9 gives you 11. Okay. All right, so that's 11. So I'm just going to insert it right there because that's equals 11. So now that's f of 11. So your final answer is, well, let's evaluate 11 in for the f function. So plug it in, and we get a grand total of 31 as your final answer. So what's happening here is first start with 5, then 5 went to 11, and 11 went to negative 31. So what's saying is 5 went all the way up to 31 in this little loop system here happening. And again, that's your final answer because so this is just an intermediate step to get to your final answer there. Now, here's the problem when it comes to compositions. The way the letters are written does actually matter. Okay? So for example, first was F and then G. Now what happens if I flip them, meaning G, F, like that? So notice very similar, right? But just the letters are flipped. But again, if you do according to the definition, so this letter is always next to this one, so you always do that first. So now notice already the way you do stuff changes. Here we did G first because that was, again, order operations being parentheses first. Here, however, now we're doing F first because order operations tells me that parentheses come first. So this one we plug in 5 in for F, get out 13, and again just insert that there, and then now find G of 13. So plug it in for G. So our final answer is negative 61. So this is a little different. So again, what I want you to emphasize is the order which you do it does matter because notice you get drastically different answers depending on which way they give it to you. So you just got to be very careful on how they do that kind of stuff. Okay. Any questions so far? We'll do some examples, but any questions on A or B so far? Everybody comfortable? Okay. All right. So the last scenario when it comes to compositions is just like the first one. Well, what if I don't give you a number, you just have a letter X? So just like the definition, we have F composed of G. So now it just comes a trick question. What is G of X? Well, G of X is 4x plus 9, 4x minus 9. So therefore, you're going to plug this whole thing in for F. So you literally just plug it in. This is the one thing it gets a lot of people who's like, well, what do you mean plug it in? Literally plug it in. Plug this whole thing in right there. Because that's what it's telling me to do. Plug just like you guys did here. You plug in a number in there, you're perfectly fine. So now plug this in for there. So we multiply. And now this time you don't get an actual number out, you get another function altogether. So again, these are the most difficult because you know it's not, you don't get a number out, right? And just for some reason it confuses people, like, what do I plug in? You plug in everything, not just, you know, pick and choose when it comes to it. So any questions on C here? Okay, so now let's actually try some this one. So given a different F, different G, let's do a couple of these. So let's first do F composed of G of 0. Oh, actually, let's make it a little, let's 3. Yeah, 3. Okay. So again, according to the definition, right, I'm just going back and rewriting exactly what it says. The F on the outside, G on the inside, and the 3 for X. All right, so if I just look at my examples, first thing I have to do is find out what this is. So what is g of 3? That means I'm going to plug it in here. This will be 2 times 3 minus 19. That is 6 minus 19, so that's going to be negative 13. Okay. So like over here, right, it's just an initial step. We're not done yet. So now I'm going to plug this back where it was. And then what I'm really looking for is f of negative 13. So now we can plug this one into here. So it's going to be 3 times negative 13 squared plus 4. So that's 169 times 3 plus 4. So your final answer is 511. Okay. Any questions on our first example? Everybody comfortable? Okay. Let's try another one. All right, so f composed of 8. So again, I'm just going to rewrite what that means. Gives me that. All right, so I'm going to find out again what g of 8 is. So plug it into here. That's 2 times 8 minus 19. What is that, 16? 16 minus, so negative 3. And now plug in negative 3 into there. So what I'm really looking for is f of negative 3. And now plug it into here. It'll be 3 times negative 3 squared plus 4. So let's see, that's 9 plus times 3 is 27. 27 plus 4 is 31. And there we go. There's our answer. All right. Why don't you guys try this one? There's your extra credit for today. And just put it in the chat, the answer to this one here. Go for it. Give me another minute and a half if you guys haven't finished it. So what do we get? So it's G on the outside, F on the inside. Figure out what F of 0 is. So plug it in 0 into here. That's just going to give you 4. Plug that back in. So final answer is whatever G of 4 is. Plug it into here. That's 2 times 4 minus 19. So 8 minus 19. And there you go. Good. Negative 11. Good. Cool. So any questions on compositions at all? Everybody comfortable?